Hi, welcome to Philos Academy. Here we are going to take some MCQs questions and I'll give you the answer and also show you how to solve it. So please, before we start, take your book, pen, calculator, and your Z table so that you follow me as I do it. Okay. Now, let's take it from question one. Question one says the sample statistic S bar is the point estimate of. Whenever you see such a question, the answer is C, is a point estimate of the population mean. Okay, so the answer is C. Now let's go to question 2 quickly. Question 2 says a standard normal distribution is a normal distribution with. As soon as you've made a normal distribution a standard normal one, then the mean is equal to 0 and the standard deviation is equal to 1. So the answer for this is B. Okay, then let's go to question 3. Question 3 says the owner of a pawn shop knows that 80% of the customers who enter a shop will pawn an item. If there are 13 customers in the shop, the probability that at most 6 will pawn an item is. Now, before you solve this question, you should know the formula for what? For binomial. Now, what is the formula for binomial? It says n combination x times p exponent x times 1 minus p exponent n minus x. It is this 1 minus p that some people write as q. Okay. Now, to solve this, according to this question, what is our p? You should know that our p is 80%, which is 0.8. 80% means 80 divided by 100, that is 0.8. So this is our p. Then, our n will be 13. The number of people that entered the shop, 13. But the question wants us to find the probability that at most 6, and at most 6 means that less than or equal to what? 6. Which means probability that s is exactly 0 or probability that s is exactly 1 or probability that s is exactly 2 or means plus, okay, or probability that s is exactly 3 or probability that s is exactly 4 or probability that s is exactly 5 or probability that s is exactly 6. You stop at 6, at most 6, okay, less than or equal to 6. Now, if I were you, I'll skip this question 3 and go and do the others. When I'm done, then I come back to it. Okay, but let's solve it. Now, what this means is that you should first find a probability that x is exactly 0. You find a probability that s is exactly 1. Find a probability that s is exactly 2. One after the other. Then you add all of them together. C'est clair? So let's see something. So let's find a probability that s is exactly 0. Okay, let's find a probability that s is exactly 0. Now, to do that, it gives you probability that s is exactly 0 gives you n. Our n is what? 13, right? Combination x. What is our x? Our x will be 0 when s is exactly 0. Okay, times p, and our p is 0.8 exponent x, which is 0, times 1 minus p, 1 minus 0.8, which will give you 0.2, exponent n minus x. And what is our n minus x? N is 13 minus x, which is 0. So you input this on your calculator and get an answer. Now, to do this on your calculator, you first press 13. To bring the combination, please check your calculator. You press shift and you check where the division sign is. You see permutation at the top of it. Okay, check where the division sign is, or you see combination. You see NCR on it. It means that press 13, then you press shift and the division sign to give you C, that's combination. Then you press 0 times, then you input 0.8 exponent 0 and the rest. When you fix it well, I believe you get 0.0058. Okay, so after getting probability that S is exactly 0, then you find probability that S is exactly 1. You find probability that S is exactly 1. Put 1 there. 1 is now here. Exponent 1, 13 minus 1. When you fix these two properly on your calculator, I think you get 0.0011. Okay. Then you do the others one after the other like that. Then you add everything together. Because of time, I won't do it. Please, I want you to do that, okay? So, when you add everything together from 0 to 6, when you add everything together from 0 to 6, you get 0. Your answer will be D. The answer will be D. You get 0.007. So the answer for this is D. Okay. So let's move. Question 4. Question 4 says, a multiple choice examination has 15 questions. Each question has 4 possible answers. How many possible answers? 4. Of which only one is correct. The probability that by just guessing a student will get exactly 7 correct is. Now pay attention. To answer this question, how many questions are there? There are 15 questions, meaning that n is equal to what? 15. Okay. Now they say each question has 4 possible answers, of which only one is what? Correct. Hence, probability that one will be correct is 1 over 4. Do you know why? The reason is you have 4 possible outcomes, possible answers, right? And only one is correct. So if only one is correct, the number that is correct divided by the number of possible answers. So that is 1 divided by 4. So that's your P. So that's probability of one success, 1 over 4. Okay. Then the question is asking you to find the probability that by just guessing, a student will get exactly 7 correct. So to do that, probability that X is exactly 7 will be equal to, it's also a binomial question, 15 combination 7. If you remember the formula says n combination x, and our n is 15, our x is 7. Okay, then p exponent x, right? So our p here is 1 over 4. Be very careful with this. This is not over. There is no division sign in this one. In the 15 combination 7, it's a different something. Then 1 over 4 exponent x, and our x is what? 7 times 1 minus 1 over 4 exponent 15 minus 7. So you input these two on your calculator. To do that, remember how to input a combination. Okay, you first type 15, then you press shift and check where the division signs are. The division, multiplication, addition and stuff. Check where they are. You see the division sign on top, right at the top of it, they've written C, the NCR. You click on the division sign itself to get a combination. Then you type 7. Then you continue. Times 1 over 4 exponent 7 times into bracket again. Please be bracketing everything, okay? Times 1 minus 1 over 4 exponent 15 minus 7. When you do it well, when you fix it on your calculator properly, you get your answer to be A. You get 0.0393. Okay, that's what you will get. 0.0393. Then you approximate it to 3 decimal places in accordance with the possible answers. You see, all the possible answers are in 3 decimal places. So you just put it in like in 3 decimal places. So that's 0.039, right? Yeah. Then let's go to question 5. Question 5 says, The mean number of customers arriving at a bank during a 15-minute period is 10. Find the probability that exactly 8 customers will arrive at the bank during a 15-minute period. Now, to solve this, you are going to use a Poisson formula to solve this. Okay, you are going to use a what? A Poisson formula to solve this. And what does a Poisson formula says? The formula says that mu exponent x times e exponent negative mu all divided by what? X factorial, isn't it? Now, what is our mu over here? When you read the question again, the question says the mean number of customers arriving at the bank during a 15-minute period is 10, meaning our mu is 10 within 15 minutes. In a 15-minute period, the mean is what? 10. Find the probability that exactly 8 customers will arrive at the bank during a 15-minute period. Okay, so our x is going to be 8. It is same time, 15 minutes, 15 minutes. So the mean will not change. Okay, so the probability that exactly 8 customers will arrive at the bank will be mu exponent x, that is 10 exponent 8, times e exponent negative mu, that's negative 10, all divided by 8 factorial. Now, to input this on your calculator, you can bring your division sign first. Then you type 10 exponent 8 times. Now, to get the E, you click on shift, okay? Then you check where, look at the top right corner of your calculator. You see a place, you see where the on is, the on, where you on your calculator, okay? Then you right under it, you see log. And right under it too, you see ln. The ln, they've written oct2 on it. Yeah. You press shift and that ln. When you press shift and that ln, it will give you e exponent. You get it? Then you fix negative 10 in the exponent. Then you come to the denominator, you type 8 to get a factorial. You also press shift. Now, look at the log right under the on, where you on your calculator. There's a log right under it. And beside it, there's a key there. The key, they've written x exponent negative 1 on it, something like that. Yeah. Then you press your shift and that key, it will give you factorial. Then you press equal to sign. Okay. When you do it well, you get 0.1126. So the answer for this is B. Now let's move to question 6. Question 6 says, for a Poisson distribution, if mean is equal to 1, then probability of 1 is. So probability of exactly 1. We know that Poisson formula says mu exponent x times e exponent negative mu divided by x factorial, isn't it? Now here lies the case that our mean is 1 over here, right? And our x2 is 1. They said we should find the probability that x is exactly 1. So if mean is 1, then we have 1 exponent what? 1. X2 is 1. Then e exponent negative 1 divided by 1 factorial. And this will give you, 1 factorial is always 1. And 1 divided by 1 is still 1. 1 times anything remains that thing. So 1 times e exponent negative 1 remains e exponent negative 1. So the final answer for this is e exponent negative 1. But when you go back to your indices, principles of indices, laws of indices, if you could recollect that any number exponent negative 1 can give you 1 over that number. So e exponent negative 1 can give you 1 divided by e. So for that matter, the answer for this is A, 1 divided by e. Okay, then let's go to question 7. Question 7 says, a fair die is rolled until 2 appears. Find the probability that the first 2 appears on the 5th roll of the die. Now look at this. Please pay attention to this. They say a fair die is rolled until a 2 appears. Until a 2 appears. Then you should find a probability that a 2 will appear on the what? On the fifth row, meaning that on the first row a 2 never appeared. On the second row, on a 2 never appeared. On the third, it never appeared. On a fourth, it never appeared. But on a fifth, it appeared. What this means is that what is the probability of a 2 appearing? You know, a die has 6 possible outcomes. 1, 2, 3, 4, 5, 6. And probability that a 2 will occur is 1 over 6. Isn't it? Probability that you get a 2 is 1 over 6. And probability that you will not get a 2 is 5 over 6. Okay, there are 5 numbers which are not 2. So that is 5 over 6, right? So on the first row, the probability that you will not get a 2 will be 5 over 6, right? Times, and on the second row, the probability that you will not get a 2 is also 5 over 6. Times on the third row, the probability that you not get a 2 is 5 over 6. Times on the fourth row, the probability that you not get a 2 is also 5 over 6. Times on the fifth row, you can now get a 2. So the probability that you get a 2 is 1 over 6. So when you multiply all this, when you do it well, I believe you get 0.0804 in decimal. Okay, so this makes the answer for question 7D. They've approximated it to 3 decimal places. Okay, so 0.080. Okay, so quickly let's go to question 8. Question 8 says a real estate agent claims that the average price for homes in a certain subdivision is 150,000. Now you believe that the average price is lower. You believe that it is lower. If you plan to test his claim by taking a random sample of prices of the homes in a subdivision, the formulated set of hypotheses will be. Now, let's look at this carefully. They say you believe that it is lower. Lower means what? Less than. Okay. Now we have HO and HA, isn't it? Now, if you recollect from our previous videos or from the class that you went for or wherever, you remember that they said HO is any statement of equality, such as less than or equal to, greater than or equal to, and equal to. These 3 statements usually go for what? HO. And statement of inequality like less than, greater than, not equal to, statement of inequality, they usually go for HA. Now, if that is the case, when we say lower, lower means less than, which is this. So we should go for what? HA, isn't it? So if that's the case, then our HA, so to state HA, the meaning that the mean average is what? Lower. Lower means less than. I get a statement of inequality should go for HA. Less than the mean. Okay, that's 150,000. So to know what the HO will be, what is the opposite of less than sign? The opposite of less than sign is what? Greater than or equal to. So 150,000. So that, for that matter, the answer for this will be what? I think the answer will be D, right? Yeah, so the answer is D. So quickly, let's go to question 9. Question 9 says, if you are trying to establish that the mean of population 1 is greater than the mean of population 2, the appropriate set of hypotheses is. Now, when you see the word greater than, you see we have HO, HA, or H1, HA, right? Now, greater than is a statement of what? Inequality, right? So you should go for HA. I hope you remember that. So, we are saying that the mean of population 1, so mean of population 1 is greater than mean of what? Population 2. So what will be the opposite? The opposite will be that the mean of population 1 is less than or equal to mean of what? population 2. Okay, yeah. Now, to put your answer in this format, you see the possible answers are not in the format you've written it. To put your answer in this format, when you group like them for this, it will become mu1. When you bring this here, it becomes minus mu2, second mu, less than or equal to 0. When you also group this one, you have mu1 minus mu2 greater than 0. So then you come and compare it over here. The answer will be D. Okay, mu1 minus mu2 less than or equal to 0 versus HA will be mu1 minus mu2 greater than 0, as you can see. Then let's go to question 10. The question 10 says, which of the following is true? The T distribution should be used when, please, this, no doubt about it. The answer is C. Okay, you can only use the T distribution when the population standard deviation is unknown. Condition 1, please keep it. When the population standard deviation is unknown at the same time, okay, not all, but at the same time, the sample size is small. When we say sample size is small, it means that n is less than 30. Okay, yeah. And the sampling distribution is what is normal. So for if you have such a condition where your population standard deviation is unknown, the sample size is small, that is n less than 30, and the sampling distribution is normal, then we use the T distribution. Okay, so the answer is C. Okay, then question 11. It said commuter students at a certain college claim that the average distance they have to commute to campus is 26 miles per day. A random sample of 16 commuter students was surveyed and it yielded an average distance of 31 minutes, I think so, and a variance of 64. The test statistic for this test is, so now here you are going to find, you'll be wondering, am I using Z or T? Am I finding Z or T? Now, to know if you find Z or T, check the type of standard deviation that it is, and also check the sample size. Now, they say a random sample of 16. So 16. So N is 16. N is less than 30. So the first condition has been met. Also, check. A sample of 16 gave a variance. You know, from a variance, you can get a standard deviation. Do you know that? Whenever you have a variance, it's very easy for you to get a standard deviation. You just take the square root of the variance to get a standard deviation. So this variance is a sample variance because it is talking about this sample. It's a random sample of 16 students was surveyed and yielded an average distance of 31 and variance of 64. So meaning this variance is referring to the sample of 16. So it's a sample variance. So if it is a sample variance, the standard deviation you will get from it also will be a sample standard deviation. So we are using T. Okay. The standard deviation is not a population one. So we are using T. So the formula says that sample mean minus population mean divided by standard deviation over root n. Standard deviation over root n. Now here lies the case that our sample mean is 31, right? So 31 minus our population mean is 26. If you say average distance, so the population mean is 26. Okay, divided by what's our standard deviation? Our standard deviation will be the square root of the variance. Okay, standard deviation is equal to what? Square root of variance. So square root of variance is, so you find the square root of the variance. Okay, yeah. Then so let's fix it like that, square root of 64. If you had been given the standard deviation, you just substitute it straightforward. But you've been given a variance, so you have to take the square root of the variance to get a standard deviation. Divided by square root of n, and our n is 16, so square root of 16. Okay. So when you fix this on your calculator, when you input it, you get 2.5. It's a positive 2.5, okay? Yeah, the sample mean is bigger than the population mean, so you should get a positive answer. If the sample mean is less than the population mean, you get a negative answer. So T is equal to positive 2.5. So the answer is C. So question 12. A tire manufacturer claims that each tire will last an average 40,000 miles with a standard deviation of 3,000 miles. Now, 49 tires were placed on a test and average failure miles was recorded. The probability that the average failure miles was more than 39,500 is, okay, to solve this, we are going to find Z. The sample size is large, 49. The size is 49, it's very large. It's large, okay? It's more than 30, so we are using Z. So Z is equal to sample mean. What's our sample mean? What's our sample mean? They said a tire claims that the last average is this. So this is the population mean. And the standard deviation is 3,000. So this is the sample mean, 39,500. So 39,500 minus 40,000, which is the population mean, divided by the standard deviation is 3,000 divided by square root of 49. So when you input this on your calculator very well, you get a negative 1.17. You are getting a negative answer here because the sample mean is less than population mean, remember. So you are getting negative 1.17. So to get the probability, we are finding the probability that Z, the question says more than, okay, more than, area more than. So we've gotten our Z to be what? 1.17. So we are finding probability that Z is greater than 1.17, negative 1.17. Now to do that, you are going to take your Z table. Okay, let's sketch a curve to represent it. We've gotten the Z, right? So let's sketch a curve. Where is negative 1.17? It will be here, negative 1.17. So they say more than, the area more than will be this place, meaning if you find this area, okay, if you find this area. So to get this area, you go to your Z table. You look for negative 1.17, negative 1.17, negative 1.17. This is negative 1.17, negative 1.1 is here. Then you trace it towards 7. So 0, 1, 2, 3, 4, 5, 6, 6, 7. So it's here. That is 0.1210. Okay. And that is the area to the left. 0.1210. Okay. So that's the area to the left. So meaning this place is 0.1210. So to get this place, to give you 1 minus 0.1210. And 1 minus 0.1210 is what? 0.8790. So the answer is B. Okay, the answer is B. Let's go to question 13. It says a waiter estimates that on its average tip per table is $20 with a standard deviation of $4. If his table seats 9 customers, the probability that the average tip for one table is between $19 and $21 when the tip per table is normally distributed is. Now to do this, we are going to find this. They want you to find between this and this. And our mean population mean is $20, right? And the standard deviation is what? 4, right? So to find the first Z, you take your first X, which is 19, okay, minus the second one. You take minus the second one. We are question 13, okay? So what's the second one? we have 20, sorry, 19, the sample mean. The first sample mean minus the population mean, which is 20, divided by, what's the standard deviation? 4 over root 9, because there are 9 customers. Okay. So when you fix it well, you get what? Negative 0.75. Is that so? Then you also find a second z. The second sample mean 21 minus 20 divided by 4 over root 9. When you fix this two well on your calculator, you get positive 0.75. Okay. Now what this means is that they said between, right? So when you have your curve, let's say 0 is at the middle here, negative 0.75 is here, and positive 0.75 is here. They say we should find the area between, meaning between this and this. To get the area between, you find negative 0.75 to the left, and you also find positive 0.75 to the left. Then you find the difference. So negative 0.75 to the left, negative 0.75, this 0, 1, 2, 3, 4, 5. It gives you 0.2266, right? Then also positive 0.75 to the left, positive 0.75 to the left, 0, 1, 2, 3, 4, 5. It gives you 0.7734. Is that not so? Yeah. So this and this. So 0.75 give us what? 0.7734. Is that not so? Minus this also to the left gave us 0.2266. 0.2266. So when you subtract, you get 0.5468. So the answer is what? D, right? Yeah. So question 14. Question 14 says, if the z-score associated with a given raw score is equal to 0, then this implies that. Now when you see any question like this, okay, the answer is D. The answer is D. The raw score is the same as the mean. Whenever a raw score is equal to the mean, you are going to get the z-score to be 0. Let's say your raw score, z is equal to x minus mu divided by standard deviation. Okay, so let's assume the x was, let's say, 10, and the mean too was 10, and the standard deviation, let's say, is 500, but it cannot be so. Let's say it's 2.1. 10 minus 10 is what? Is it not 0? And 0 divided by any number or whatever number is what? Is 0. Okay, so whenever you have a raw score which is the same as the mean, okay, your z-score is going to be equal to 0. So the answer for this is D. Then question 15, which of the following does not apply to the normal distribution? Now, to answer this question properly, you should know the features, the characteristics of a normal distribution. Okay, so let's see the possible answer. The normal curve is unimodal. Is that true? B, the total probability under the curve is 1. Is that true? C, the normal curve is symmetric about its standard deviation. And D, the mean, median, and mode are all equal. The answer is C. C is odd. C is odd. Out of all the possible answers, the odd one is C. Okay, you can refer to your slides or your book to check for that. The features, the characteristics of the normal distribution. Now, question 16. The area under any normal curve that is within 2 standard deviation of the mean is approximately, the answer is A, is approximately 95%, which is 0.95. Okay, between one standard deviation is approximately 68%. Between 2 standard deviation is approximately 95%. And between 3 standard deviation is approximately, I think, 99.7%. So the answer for this, they said two standard deviations. So the answer is A, 95%. 95% has been converted to decimal. 95 divided by 100. Okay, 0.95. So let's see. Question 17. A loan officer has indicated that 80% of all loan application forms have zero errors. If six forms are selected at random, if six forms are selected at random, the probability that exactly two of them will have at least one error is. To solve this, we are finding the probability that at least one of them, at least one error is. The probability that exactly two of them will have at least one error. Okay. Please take a look at the question once again. It said a loan officer has indicated that 80% of all loan application forms have zero errors. But the question is asking us to find at least one error. Are you following? Now, if 80% have zero error, meaning that 20% have at least one error. Do you get it? Meaning that what? 20% have at least one error. So for that matter, the probability of at least one error is 20%, which is 0.2. The probability of a success for at least one error is 0.2. And our n will be what? 6. That's 6 forms. So the question is asking us to find exactly 2. Probability that s is exactly 2. So it's binomial. So that's 6 combination 2, then 0.2 exponent 2 times 1 minus 0.2, which is 0.8 exponent what? 6 minus 2. So in one of the questions, I show you how to fix the combination on your calculator. Okay, so when you fix these two properly, you get what? 0.24588. And 0.24588 is approximated to 0.246. That's why the answer here is D. 3 decimal places. So question 18. A statistics instructor, that's with at least 20 years of experience teaching the same course, has established that 10% of all students who take his course receive a failing grade. Now, if 10 students have enrolled for his course next semester, the mean number of students who will fail is, they want you to find the mean, the expected mean, okay? So, and you know, expected mean is equal to n times p. Now, according to him, he said 10% of his students will fail, meaning his p is equal to what? 10%, which is what? 0.1, isn't it? Then the question is asking that if 10 students enrolled, meaning if n is equal to 10, we should find the expected mean. So to do that, our n is 10, right? Times our p is 0.1. 10 times 0.1 gives you what? 1, 1. Okay. So the answer for this is A. 1 is the same as 1.0. So question 19. If IQ scores are normally distributed with a mean of 100 and a standard deviation of 20, then the probability of a person's having an IQ score of at least 130 is, the answer for this is D. The answer for this is D. The reason is we are finding, it's like if IQ scores are normally with mean, so our mean is what? 100. And the standard deviation is what? 20. So the probability that a person having an IQ score of at least 130, so our x is 1. So to find the z score will be 130 minus 100 divided by 20. 130 minus 100 divided by 20 gives you what? That's 30 over 20, which gives us 1.5. But the question says at least 130. at least 130. So when you sketch a curve, let's sketch a curve and see at least 130. So we now have our 1.5 here, right? 1.5. At least means minimum. The lowest should be this. So meaning you should find this area and subtract it from 1 to get this place. So to get this area, 1.5, we go to the z table and we check 1.5, 1.5. 1.5 give us 0.9332, 0.9332, 0.9332. So meaning this place is 0.9332. So 1 minus 0.9332 gives you what? 0.0668. So the answer is D. Okay. Then question 20. The time it takes for a dose of a certain drug to be effective as a sedative on lab animal is normally distributed with a mean of 1 hour and a standard deviation of 0.1 hour. If x represents this time, then probability that x is greater than 1.1 is. So to do this, we will find z. Our x is what? 1.1. 1.1 minus, what is the mean? The mean is 1 divided by, what's the standard deviation? 0.1. We are using the formula z is equal to x minus mean divided by standard deviation. So 1.1 minus 1 is 0.1, isn't it? And 0.1 divided by 0.1 gives you what? Positive 1. Is that not so? So when you get positive 1, meaning you are finding the probability that z is greater than what? 1, isn't it? So to get that, meaning we are finding, if this is 1, positive 1, we are finding this side. So together, you go to your z table and look for 1.0, that's 1. It gives you 0.8413, right? 0.8413. So this place gives you 0.8413. So to get this side is 1 minus 0.8413, isn't it? Which will give you 0.1587. Okay. Another way of checking it is that you can check positive 1 on a negative z table to get the answer straightforward instead of you checking it on a positive z table. That's 1587, as you can see. Positive 0.1587. You see. So the answer is what? D. 21. The area under the standard normal curve between z equals negative 1.68 and z equals 0 is. Now to solve this, when you sketch a curve, please, if you really understand this, there's no need sketching the curve. I'm sketching the curve as an illustrative, like to guide you on what it means and wherever. So, you know that in a standard normal curve, the middle is 0. And z, when z is negative 1.6, let's assume it's somewhere here. So negative 1.68. So the question wants us to find the area between 0 and 1.68. Twin. Okay. So to get this, you go to your z table and you check area to the left of negative 1.68. So negative 1.68, you have negative 1.6 here, then 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. So it gives us 0.0465. So area to the left of this is 0.0465, isn't it? Yeah. Then we also find area to the left of 0. In fact, without checking the z table, we should know that area to the left of 0 is 0.5. Or let's check it. 0. 0.00. See, 0. 0.5000. So area to the left of 0 is 0.5. So to get the area between the two of them, you say area to the left of 0, which is 0.5, minus area to the left of negative 1.65, which is 0.0465. When you subtract and you do that properly, you should get 0.4535. So this makes the answer for this A. Question 22. If x is a normal random variable with a mean of 15 and a variance of 9, then probability that x is less than 18 is... So we've been given a mean and a what? And a variance, isn't it? And you remember, the formula for z is what? X minus mean divided by standard deviation. But we've been given a variance. Remember, whenever you have a variance, to convert a variance to standard deviation, it is the square root of that variance. That will give you a standard deviation. So to get our z here, our x is 18. You consider the s as 18 minus the mean, which is 15, divided by square root of 9. Now 18 minus 15 is what? 3, right? Divided by root 9. And root 9 is also 3. So 3 divided by 3 all give you what? 1. So your z square is 1, right? Now, the question is asking us to find less than. So if let's say 1 is here, the area less than 18, which is less than 1, okay, will be this side. So meaning we should find the area to the left of 1. So to do that, you quickly check for 1.0. That's 0.8413. So the answer is 0.8413. 0.8413. So the answer is B. The answer is B. Question 23. Suppose the height of a population of basketball players at a certain college are normally distributed with a standard deviation of 2 feet. Now, if the sample of height of size 16 is randomly selected from this population mean with a mean of 6.2 feet, the 90% confidence interval for the mean height of these basketball players is... To solve this, they want you to find the confidence interval. Okay. Now, to do this, what's the formula for confidence interval? Now, you should know if you are going to use Z or what, or T. To determine if you are using Z or T, check the sample size and also check the standard deviation. Here, we've been given a population standard deviation, so you should use Z. Though the sample size is small, but still, since you've been given a population standard deviation, then you still have to use a Z. Okay, look at a population of basketball players at a certain college are normally distributed with a standard deviation of 2 feet, meaning that this standard deviation is referring to the population. So it's a population standard deviation. Though the sample size is less than 30, but still, you still have to use the Z. Okay, so when you are 90% confidence, your Z score is what? 1 point. Your Z score will be 1.645. You can also use 1.65, okay, or 1.645. Now, what's the formula for confidence interval for Z? The formula says sample mean plus or minus Z multiplying standard deviation over root n, isn't it? So this will give us, what's our sample mean? What's our sample mean? Our sample mean is 6.2. If you read it carefully, they say if a sample of 16 is randomly selected from the population with a mean of 6.2, meaning this mean is referring to this sample. So the sample mean is 6.2 plus our Z is plus or minus our Z is 1.645 times, what's the standard deviation? The population standard deviation is 2 divided by root n. Now n is 16. So this will give you 6.2 plus or minus. When you multiply this properly, 1.645 times 2 over root 16, you should get 0.8225. Okay, so to get your answer, to get your final answer, you say 6.2 minus 0. Let me do it for you to see. So 6.2 minus 0.8225. What will it give you? It will give you 5.3775, isn't it? When you also take 6.2 plus, that's the meaning of plus or minus, plus 0.8225, it also gives you 7.0225. Okay, so the answer for this will be what? B. That's 5.378. It has been approximated to 3 decimal places. 1, 2, 3. You add it to this 1 to make it 8. You approximate this to 3 decimal places. You approximate these two to 3 decimal places. So the answer is B. Okay. Then 24. The most common confidence level and the corresponding Z values are listed below. Which corresponding Z value is incorrect? Let's see which of them is incorrect. Please, I think A is incorrect because when you look at, when you are 95% confidence, your Z score is 1.96. So this is correct. When you are 98% confident, your Z score is 2.33. It's also correct. When you are 90% confident, your Z score is 1.645, the one we used here. So it's also correct. But when you are 99% confident, your Z score cannot be 1.28. It's totally wrong. I think your Z score should be 2.58 or so. Yeah, 2.58. That should be your Z score when you are 99% confident. In fact, 99% confidence should be bigger. The Z score of it should be greater. It should be more than 95, 98, and 90. So imagine giving you 1.28. You should know straightforward that this is totally wrong. Okay, even if you don't have any idea about confidence interval, when you look at it, yeah, let me see this. 90% is going for 1.645. 95 is 1.96. 98 is, you see, it's increasing. So 99 cannot be small like that. No. So even if you don't have any idea about this, when you take a critical look at of how the thing is going, you should know that A is incorrect. Okay. So question 25. In a random sample of 150 drunk drivers, 91% were males. The 99% confidence interval for the proportion of drunk drivers who are male is, so to find the confidence interval for proportion, the formula says P hat plus or minus Z multiplying square root of P hat Q hat divided by N. Now what is our P hat? Our P hat is what? 91%, which is 0.91, isn't it? Then our Q hat will be equal to 1 minus 0.91, which will give you what? 0.09. Then what again? Our N is what? 150. 150. And what will be our Z? Please, when you are 99% confidence, okay, when you are 99% confident, your Z score is 2.578. Okay, here I said it was 2.58. Yeah, it's 2.578. It's when you approximate it to decimal place, to give you 2.58, as I said. Okay, so 2.578. So let's substitute and solve. Then you have what? P hat, which is 0.91, plus or minus Z, which is 2.578, multiplying square root of 0.91 times 0.09, that's Q, divided by 150. you get 0.91 plus or minus, or you multiply this. When you put this on your calculator, you should get what? 0.0602. Okay, please remember this place is called margin of error. The place I've circled is called margin of error. Okay, here too, here too. This part is called margin of error. Okay, so then you take 0.91 minus 0.0602. Please take your calculator and do that. When you subtract it properly, you get 0.8498, isn't it? Also, 0.91 plus 0.0602 also gives you what? 0.9702, isn't it? 9702. So compare it with the possible answers. So the answer will be B. Okay, yeah, the answer is B. So question